So everyone, it's been my pleasure to be here as the moderator of one. It's the post-tea session because the last session is there. Normally this is the session where everybody goes to sleep. But I can assure you personally that this is going to be a very exciting session. You've already heard through the earlier session, and you can see the excitement and all the energy that he has, and that's rubbing off on all of us. So I can personally assure you once again that it will be a very exciting session. The empty chairs are the ones who are going to be in this session. Okay, I don't think I need to go once again into the introduction. We already heard it this morning. Prolific writer, accessing 1,000 mailing lists, 600 messages a day, etc., etc. So I'll just let him have the floor. We are running about 25 minutes behind schedule, so I think we have a few or not. What I would suggest is that during the session, because this is a very practical session, there will be a few terms or terminology which will be thrown into the presentation. If there's anything that is in the presentation right there and then that you find you must need to know before one proceeds to the next slide, feel free to interrupt him and just ask the question right there and then. However, if it's a deeper question, a strategy question, or a global question, I would suggest you stay until the end, and we can address it when we have the question and answer the Q&A session post-presentation.
Thank you, Suchin. Everything can be downloaded from this site. This is URL www.aki.or.id.
Nothing.
Is it working now?
Yeah.
Okay, sorry. This is the next start. The OWP Merdeka. Okay. As usual, if you browse this site, there is no graphics, nothing, all text. Just click the right button, download. That's it. Okay? Nothing fancy. That's almost time. Finish?
No.
No, not yet. I have to confess though, I'm still uploading the updates. It's not finished yet. It's too slow. Okay. Finish. Okay. What's that? Broad overview what I'm doing. Community-based telecommunication infrastructure, actually Richard, name it Telecommunication Liberation Front. Sorry, Richard. You named it like that. The physical infrastructure we are looking at is an internet base. We replace the copper wire, the last mile, using wireless, and we connect to ITG, which is Internet Telephony Gateway, and connect the Internet Telephony Gateway to TBS. Basically, what we are trying to do is to shift the telco traffic into Internet. Okay, we bypassing the long distance telco traffic into the Internet. We build the community-based telecommunication infrastructure network. Okay, conceptually, this is totally different than the one adopted by the Indonesian legal framework. The Indonesian legal framework, everything must come from the government, run by the operator, for the Indonesian people. In this infrastructure, the paradigm is totally shifted, totally different. It's not from the Indonesian government. This is from the Indonesian people, not from the Indonesian government. By the Indonesian people, not by operator, not by investor, not by World Bank, not by IMF, for the Indonesian people. From Indonesian people, by people, for people. Not government, by operator, for people. So the concept is totally brutal. The legal framework, the Indonesian legal framework cannot adopt this kind of concept. Seriously. They are looking. Okay. little bit radical. This can be done mainly because the cost of the hardware is getting lower. The previous concept, the previous paradigm they use, the Indonesian legal framework use, they always think the telecommunication equipment is very expensive. Not many people can buy that kind of equipment. They need a big investor. The equipment can only be run by skilled people. While the technology is moving, the technology is changing, the equipment is getting cheap, so cheap, and because of the operating system, computer and everything, it's very easy to install, it's very easy to run. Because of that, the paradigm is shifted. Okay, it's very simple. Now, I will slowly drag you down into the detail. I cannot go into very detail. I normally take about 1 day. That is only 1 hour. Brief overview for wireless LAN. So I'm going to the wireless first. The next step I will go to the voice over IP. Brief overview for wireless LAN for metropolitan area network. So wireless local area network for cities, for municipals. Okay. The objective to be able to build our own wireless internet infrastructure, replacing the telco last mile, able to interconnect our surrounding neighborhood and share the internet access. Share is the key. By sharing the internet access, we can reduce the cost. In normal internet connection, it costs about $400 per month to have 24-hour internet connection. By sharing with the surrounding neighborhood, it costs us only about $20 to $30 per month per house. Okay, so sharing is the key to reduce the cost. The more people share, the lower the cost. So why lower the cost in the long run? No need to rely on telco. The wireless, using wireless, there is no need to rely on telco. In fact, we build our own telco at low cost. Okay, I have to tell you, the equipment is very similar to the one that we use. If you see on top of that computer, maybe it's difficult for you, the one to sit over there. I have the picture later. The one that put on top of that computer is the access point. The same access point used for building our wireless network in the cities. Actually, it's something like that. It costs in Indonesia, one access point, it costs about $130, $150. So it's not that expensive. The wireless LAN card, it costs about, in Indonesia, it costs about $80. Okay. But the government sometimes sweep the equipment. But that's okay, we buy another one. This is the overview for this slide. I will move slowly to another slide. How to install, bypassing last mile, interconnection to the neighborhood, and some references. This is the equipment we need for the installation. Because we do it outdoor, this is not for indoor installation. I know the protocol and everything is designed for indoor usage, but we use it for outdoor because the equipment is cheap. It's nothing to do with the performance because it's cheap. Okay, we need a PC, we need the wireless LAN card, we need an external antenna, and we need a cable to connect the wireless LAN card and the external antenna, and that's it. I think I have the cable. This is the cable. If you see, it has two different connectors. One is small, one is big. The big one is for external antenna, the small one is connected to my wireless LAN. That's how we extend the distance using external antenna. Okay? So, we normally make this kind of cable, but not this one, different one. So basically we bypass the last mile, the telco last mile. Okay? no modem anymore, no phone modem. We use wireless LAN and we use external antenna and we replace the last mile, the telco, using wireless. The speed for 1 to 2 kilometers we can get for 11 megabit per second. 5 kilometers to 8 kilometers we can get like 1 to 2 megabits per second. Still much higher than normal phone lines. Okay. Having the internet connection 24 hours connected, and then we can connect our surrounding neighborhood to the hub. Well, it's in my case, the hub is Pentium 166 megahertz. I bought it for $35 in Indonesia. Running Linux, and it runs 24 hours. So it connect, I connect to the surrounding neighborhood. Sometimes I use the cable, the local area network, OWP cable. I have the pictures, so later I'll show you the cabling, and sometimes using wireless, so depending on the distance. This is my home installation. This is my gateway. This is Pentium 166 megahertz, cost me $35 used. Okay, the hard drive is only 2 gigabyte. Okay, this is my antenna. If you see the tower, there's a plumbing pipe. I am a retired civil servant, so I cannot afford to buy a big tower. So I use plumbing pipe, put it in the wall, and I mount the antenna on the pipe. Okay, it's good enough. It works. My home is 2-story building, so the height is about like 7-8 meters. Okay, so we are looking at that kind of height. The good thing with plumbing pipe, the government doesn't realize that this is a wireless antenna for internet. They think this is for television, so that's okay. Okay, this is my workplace. So I connect using my Pentium 1. I connect my PCs at home. This is my home. If you see the PC with dark monitor, that's 486. I use 486 as my terminal to reply my mail. This is text mode. Now go to the Linux server, which is the Pentium 166 megahertz. Okay. So I use it costs like it's free actually. Somebody gave it to me. So that's how I built the network within my house. And then I drill a hole in the wall to connect my neighbor. So that's how we built the neighborhood network and share the costs. Okay, I paid $30 to my friends in the apartment about 1 kilometer away, and my other neighbor shared me some money. So basically, I don't pay anything. These are the good references to start with. Okay, I'll show you a little bit on the how to set up the neighborhood network. Okay, finish with this one. Gradually move to another one. Okay, not this one. This one, neighborhood network. This is done by my friend Michael Sugiyadi. He is in Sudan right now. He's building a network in Sudan, in Africa, wireless network in Sudan. I got all the pictures from his website. He really built lots of neighborhood network in his cities. This is the topology again. Basically what we need is a hub, the normal local area network hub, LAN hub, either 10 megabits per second or 100 megabits per second with unshielded twisted pair cable, UTP cable, to connect all the nodes. This is the hub. I think it costs about like $60 or something. Actually, the one I use at home, I bought it used. It costs about $10, so it's cheap. Okay. We put the hub in casing for outdoor usage. if you see the plastic plumbing, that's where the cabling is. For environment protection, we use plastic plumbing, so there is no water coming to the cable. Okay, this is inside the casing. You can see the hub, you can see the power supply. We can connect to the power. That's how we power the hub. Okay, and we run the cabling through sewer system to the sewer to the neighborhood. See, this is real. What I'm talking is real. It's happening. Okay. The most difficult part is running the cable across the street. So we have to dig something. There's a trick in Indonesia to do those things. Okay. In Indonesia, if you see the road in Indonesia, sometimes they put a bump, so people cannot to reduce the speed. Okay. What was it called? Speed breaker. Okay. The way we do it in Indonesia, we ask the leader in the neighborhood, do you need a speed breaker? I do it for you. So it's fun. So that way we can run the cable and rig the houses and everything. This is the installer. It's a real man. It's a person. We cannot rig. We have to do it. Okay, so I'll slowly guide you into more detail. Not this one, this one. Okay. Let me give you some view of the infrastructure. I will not give you the detailed calculation. I'm afraid you will be run away after this. So this is only the pictures and everything. Nice thing about the technology. At the ISP or the access point, those small things, we put it on the tower, on top of the tower, because the power is so slow. Normally we run for like 13 milliwatt to 15 milliwatt. It's so slow. We cannot run cable too long. So normally we put it on top of the tower, very close to the antenna. So the tower may be tall. Okay, I have to tell you something. The most expensive in the system is the tower. It's not the equipment. The access point, the wireless LAN card is the cheapest one. The most expensive one is the tower. In Indonesia, the tower is normally cost about 400 million rupiah, which is what? 100,000 US dollars, something like that. Hey, is it like that? No, 40,000, sorry, 40,000 US dollar tower, something like that. So we are looking at that number for tower. That's why we normally speak to the broadcasting station, and we rent some space there, and we use their facilities there. If you are on top of big building, can you see the picture? This is actually on top of big building. This is on top of Institute Technology in Bandung. This picture taken 1997. We are running the facilities at 2 megabit per second, so the earlier version of what we are using right now. So this is running only at 2 megabit per second, and it connects to Pro University in Bandung. Okay. Okay, now let me show you how it looks like, the installation, the access point, and how we can connect the surrounding, what kind of equipment we need. This is the website. Okay, I will give you some briefings on access point equipment, antenna, and the wireless internet point of presence. The access point. This is one example. We have the example, real running example in this room. Okay. Normally an access point, if you see on the back, it has a UTP, local area network connection, UTP connection, and connection for the antenna. Okay. And then we need a card, wireless LAN card for your PCs. Normally we run it on desktop, so we need an interface from PC MCIA to ISA bus or PCI bus. That's type of bus on your motherboard, on your PC. The latest model of the computer normally use PCI. Okay. Oh, sorry. But some cards is built in the adapter and the PCI card built in into one single card, so we don't need to buy two equipment like this. Let me see. Let me show you the antenna. We skip the indoor antenna, the cellular antenna, the access point. Okay. There are several models of antenna for the access point. This type of antenna is an omnidirectional antenna, a vertical antenna. The radiation pattern is 360 degrees. Okay. If we stretch the antenna, make it taller, the gain is increased. You can see the gain. This is 8 dBi. The other one is 12 dBi. Don't worry about dBi and everything. Anyway, the gain is increased. Of course, the price also increased. Okay. Now, to increase the gain more, we reduce the radiation. This type of antenna is 360 degree radiation all over the antenna. By reducing the degree of radiation, this type of antenna is 180 degree radiation. We can increase the gain of the antenna. By increasing the gain of the antenna, we can reach longer, we can extend the distance longer. So that's how we do it. If you see the antenna at the base transmitter station, BTS of the cellular phone, the antenna is very similar to this one. The base transmitter, the BTS for the cellular phone, using this kind of antenna because it's more effective than the vertical antenna. Okay. If we reduce the radiation pattern to 90 degrees, the gain increases. Of course, if we can reduce it to smaller degree, very narrow beam width, normally used at client side at our house, it's not an access point at client side, then we can have this kind of antenna. The beam width is very narrow, but the gain is very high. Okay. This is type of antenna we normally use. Parabolic antenna. Actually the antenna is the white one. Inside the white enclosure is a dipole antenna. It's only 6 centimeter. So it's so tiny. Okay. The gain is 24 dBi. This kind of antenna normally used in our internet cafe and everything. In my house, I use a smaller antenna than this, a little bit smaller. Okay. Now, power amplifier. This is illegal because it will interfere. Exactly. And it will, during the design of metropolitan area network, we calculate very tightly so we can reuse the frequency from one region, from one cell to another cell. So we cannot use power amplifier. But the equipment is available, but I not really recommend the power amplifier. So this is the power amplifier. Okay. What you will need is, oh sorry, this is Indonesian language. I forgot to change it to English. What is in English? Lightning protection. Lightning protection. This is lightning protection. So if there is lightning strike, our equipment still okay. The major problem in wireless is lightning. Okay. Now, how we install the equipment? We call it wireless point of presence. This one is point of the left hand side is our access point, running in a single frequencies with a single access point with an omnidirectional antenna, 330 degrees radiation pattern. On the right hand side, there is an example of four different configuration. Basically, in my house, I have a PC with a wireless LAN card inside with parabolic antenna. That's it. That's at the client side. At the access point, we have antenna, we have lightning protector, we have access point, a hub for the LAN, and connection to the internet. Okay, that's 360 degree. If we use different antenna with 180 degree radiation pattern, we can use in single tower, one tower, we can use two access point with two lightning protector with one hub, and it can connect to the internet for 24-hour connection, and it can serve the client on the right hand side. I cannot see the slide. How to treat the legal system in Indonesia? I have to say in Indonesia, not in your. Don't do it in your house. How to treat the legal system? License is only needed for commercial service if we connect to telco infrastructure. There is no license for non-commercial, no fee, zero. It's not connected to telco. So that's the trick. As long as I'm not asking for money, I don't have to get a license. As long as I'm not connecting the infrastructure to telco, I don't have to get any license. So that's the trick. Okay. Yeah, well, we have to be tricky in Indonesia. Some historical background. The government telling us, the Indonesian people, starting 1st January, they will increase telco tariff by 30%. And that's serious. Okay. The government doesn't really like the Indonesian people, so they like to increase the tariff. Okay. So we talk to each other on the mailing list on the internet. On 6th January, the first gatekeeper is code switch. It's basically software. Code switch actually is running this particular gatekeeper on the 6th January. I installed it on Pentium Pro, which is Pentium 2, 200 megahertz. The memory is 64 meg. Hard drive is 2 gigabyte. It served the whole country. But now we have 150 gatekeeper. The switch is 150. I'll show you how to install the gatekeeper after this. It's very, 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 very simple. Okay. On 12th January, we declare the independence of Indonesian telecommunication. So we are success. We are okay. The underlying system, no government support, no government funding, no web funding, no IFM funding, lots of volunteer, lots of donation of bandwidth and hardware and everything. Everybody contribute. That's nice. It's nice. It's nice to be in that kind of community. Everybody contribute. I'm not really making money. I'm just looking for ways to handle stuff. Some statistical data. After 2 months, less than 2 months actually, we have 2,500 registered users. I am not a registered user. I don't want my name to be registered in the phone book. This is my experience. After I telling people my phone number, people call me, and I have to answer the phone. This is the real phone over internet. Okay. And then we have 150 voice over IP gatekeepers, the code switch. We have 6 countries neighboring with us. This is not the legal, not the formal telco of that country. This is Indonesian, sometimes the actual residents running their own gatekeeper and their neighboring gatekeeper, their gatekeeper with us. This is not the formal telco. You are welcome to neighbor your gatekeeper with us. It's free, no charge, we are having fun. We have 6 countries so far. Approximately about 100 calls per day in the major gatekeeper. You have to remember, we are running this system only the last 2 months. This is still new. Okay. The gatekeeper specification, Pentium Pro, Pentium. This is from the government.
would like to ask about how you set the overseas without label, because the company is free or what?
Set to overseas?
Yeah.
For the voice of right?
Yeah. Voice over IP, but how you set up with another telephone guy overseas?
Oh, okay. On the internet, the normal internet we are using for web, for email, and everything. So the same internet we are using right now. Okay. At the overseas side, our friends on the other side, they set up a gatekeeper, the phone switch. I forgot to show you how to set up the phone switch. It's very, very easy. Maybe if we have time, I can show you. I promise you, it's very, 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 very easy. Takes about 30 seconds. Okay. So the other guy set a gatekeeper, and they set the gatekeeper to neighbor with us. Okay, that's the phone switch. To connect to local phone line, some of my friends buying internet telephony gateway and plugging it into telephone overseas. So that's all.
Internet, but how do you click connect to the switch, telco switch? It has
okay.
Yeah, the CDR should report to the switch, and they will charge you. So how you?
Okay. Actually, this slide. So our friend on the other side, they buy internet telephony gateway. Okay, the FXO, they connect FXO into telco phone line, not phone switch, phone line. That's it. And then we can call the local phone, local handphone. That's it. We are not connecting to the telco phone switch because the government will allow us to connect to the telco phone switch. We are using phone lines.
Not yet. Okay, what he's saying is that you have a company at one end and you buy a network equipment which connects to the internet, that connects to the gateway, travels across the net, and then connects to the gateway at the other end. So you're not really connecting to the telephone.
But that means your telephone using the VoIP on the net can call to public phone.
Sure. I can broadcast each I said can be exact number used by your telephone. So if I subscribe to your telephone and I get the line and the number, right? Two things. We get the line and we get the number. Each line has its own number. So I program the internet telephony gateway, each port for each number. The exact number I get from your telephone. So the internet telephony gateway will broadcast the number to the gatekeeper, the voice over IP phone switch. The gatekeeper then broadcast to the other gatekeeper. Okay. At normal power, which is about 30 milliwatt, we are looking at, depending on the antenna, if we are using 24 dBi, which is quite big antenna, it costs about $75 the antenna. It can go up to 8 kilometers. Yeah,
I can find that.
Huh?
Where can I buy the antenna?
Where can you buy the antenna? Loss. I normally no problem.
It goes up to 12 kilometers. Up to 12 kilometers? It goes up to 12 kilometers.
So, yeah. If you want to go further, you can use equipment something like wave rider. Wave is wave, rider is RIDER.
And I can use it as a hub and then I can hop out.
Yes, the maximum distance for wave rider I think about 24 kilometers to 30 kilometers. So it's further away. But the equipment is a little bit expensive. One equipment costs about $1,500.
Any more questions?
Done. Yes.
This is very tricky on your side because you are having the long lessons. You are trying to escape the every problems you are going to face if you have to the telecom. But in our young case, we are also faced with such system in early 97. But the problem with us that after our testing, like you just took the free license and free everything. But after the 1 year later, the government has licensed 2.4 give
The
it.
government put
Yes,
license.
it's licensed so we should pay for that. So this is the one of the main
How
reasons.
much? How much you have to pay? In Indonesian case, sorry.
Sorry, just I cannot say just the exact number right now. If you wish, I can give this how much they are asking. So there is no license fee. And also, I'm just interested. Of course, when you are using the voice over IP and services, although you are just not paying, but still you are using the bandwidth from ISP.
Yeah, we pay for
Yes.
it.
Yes. How much you are paying for ISP? This is question. And do you know your traffic size at the moment? Because with the increase of the traffic for the voice over IP services, it became also problem for the ISPs. So sometimes the ISPs have to ask you to pay.
When the government, Indonesian government put tariff for 2.4 gigahertz. Okay. At first they put 20 billion rupiah, which is what 2,000 US dollar per node per year per node. We are looking at node per node 2,000 US dollar per year. Okay. Of course, nobody can pay that. That's too much for us. The equipment costs only few US dollars. The license costs 2,000. That's ridiculous. So the community negotiate with the government. We have building lots of people, lots of community. They negotiate with the government. The last consensus is 2.7 million, which is 200 something, 230 US dollar per year per access point. So they are not looking nodes again. They are looking for access point after negotiation. Okay, so that's the latest one. Fortunately, 2.4 gigahertz is a ham radio band. If you know, it's a ham radio band. I'm a ham radio. I'm a licensed ham radio. I can operate my equipment in this frequency. My license cost me about $5 per year. It's okay. I use my ham radio license. Almost free. So that's how it works. That's from license side. Now, what's the other question? Sorry, I forgot. What's the other question?
How you are the
The voice of traffic, the traffic, the bandwidth.
the traffic issue.
Okay. Depending on your compression technique, the most compressed one is G723.1. Okay, the bandwidth, you don't need to remember the number. The bandwidth, if you use full duplex, it requires about 10 kilobit per second, full duplex operation. For half duplex, it requires about 5 kilobit per second. But in half, if anybody, full and half duplex? Okay, in full duplex, you maybe know. Okay, the other for the others, in full duplex, when you talk, you can listen simultaneously. That's full duplex. In half duplex, if you talk, you cannot listen. It's like walkie-talkie. So in half duplex, you have to talk like this. Hello, how are you? Over. That's it. I'm okay. Over. It's like walkie-talkie. Exactly like that. That's half duplex. So we are looking at that kind of bandwidth. The way we set up the infrastructure right now, depending on the bandwidth at the proxy server, everybody has to know how much bandwidth they have. Like for dial-up, we normally have 33.6 kilobit per second, 56 kilobit per second. Sometimes they allow 2 voice over IP running in dial-up. In my case, I'm using wireless 24 hours connection to the internet. My bandwidth to the internet is 256K bps 24 hour. It costs me $30 per month for me. But it doesn't happen for most people. For dial-up, if you run dial-up all the time in Indonesia, it costs about $250 US per month. Dial-up.
I'm from India, but now I live in Canada. What I Are you able to do that?
Yes.
Some of us were experimenting with using this kind of voice over IP, and the government woke up, and the result of such experimentation for policymakers was that they realized that perhaps the telephone bills are too high, and the consumers, all the consumers who use telephones benefited from this stealing business that we were involved in. And we got almost a 40% reduction in telephone costs, direct telephony costs, and the major telephone company has reduced the cost of dial-up service for internet work even further than that. So there can be other spin-off from this exercise, not only providing the last mile connectivity, but also to the whole band of users of telecommunications. Because they realize that if they don't reduce tariff, everybody will start stealing. So rather than booking the people and finding out where they are, because they are such a big country, they preferred to bring down the tariffs. So this can be one of the policy outcomes in a more positive
Is
way.
it possible for you to take the web so for us to come?
Yeah, maybe you can take it and give it to them.
No, they won't listen to me. I am ordinary Indonesian people.
Well, these are lobbying issues that can be addressed.
Your help will be very grateful.
I just want to share with you the experience of ISP. One thing is very good. When we started, there was 95, there was no ISP. And the concept was the first one to launch ISP. So we know the dealing troubles, the processes which we have gone through, and then we created ISP platform which worked as a pressure group. And the one thing which came out is, multi-metric, which we are talking about. In Pakistan, we don't have a multi-metric. It is like when we dial up, it's like dialing up a single call. And how long you are connected, we are not going to charge you anything. And this is very small. And this worked in the case of Pakistan. And it can work in the case of each and every country. What we need is, we have to organize our people who can work as a pressure group, and we should work with the telecom companies, and they can work out their problems. Similar to the case of, we were talking about these frequency allocation. We have a frequency allocation board through which we normally can, we are using wireless from one point to another point. That's a point to point. But the cost of antenna is very, very high. Still it's between 10 to 15,000. We are talking about going more than 256 and 1 megabit or more than that. And we are talking about kilometer of 40 and 100 kilometer, something like that. So this is what we are using. But the problem is getting frequency from the board, getting approval, going through all these problems. But the cost of tower is not that high in Pakistan. The cost of the equipment in the tower antenna is high.
For 40 kilometers, not very expensive.
I would like to share with you another phenomenon which is happening in Karachi. We were talking about the public building, the vertical building. The people living in the vertical building, they can have a debit directly through the telephone line and connecting their server, and they are putting up a router, and then they have a cable network. I mean, the cable network inside the building. They are using the existing cable network, and they are using the multimedia plus internet on a single,
cable.
And they are organizing it through sort of a organization which they create on their own. Thank you.
Great session. I think there was a lot of information to absorb, and it was a good idea to actually get the URL down at the beginning so that you can download the PowerPoint presentations, as well as be able to contact him on one of the 1,000 lists or email personally. I'm sure you can add to the 600 messages a day that he gets anyway. we learned today, very interestingly, not just the theoretical aspect of Wi-Fi, but also about practical implementation, and to actually see somebody who's gone through all the difficulties of setting it up and making it work. Wi-Fi, incidentally, was a protocol which was designed more for a local, small area. It wasn't designed really for extending it to these long distances, but there have been pockets of experimentation, including the one with the birthday, which have been able to extend this to a much longer distance. Similar to this experimentation and this kind of work, there is another initiative which is taking place in India that I'm aware of, which is being done by the Media Lab Asia. They have extended also the protocol to 20 plus kilometers and also to 30 kilometers along the river Ganges. So the idea behind taking Wi-Fi, which is really meant for a local protocol, to take it to this level, as was rightly pointed out, is that the spectrum is free in most cases, and in other countries there's an expectation that either it's going to be at a very low cost, or maybe they will also make it free. And the equipment that conforms to the standard is also very low cost because it's being mass produced. So there's a clear advantage of using the Wi-Fi protocol and to implement it in your own way, in your own setups that are there. Voice over IP, again, as was rightly pointed out there in the Canadian experience, has been used so-called illegally by people, but the implementation, one has to keep in mind, has been done at various stages. What we're here talking about is only the end-user experience of using voice over IP. The voice over IP protocol has also been used by carriers to lower the cost and thus the reduction in the prices. These kind of gateways that can be set up actually offer an alternate means of communication. And as was explained, it can be done in a very short time, in a very simple manner. So I hope that the next session that we have, maybe in a year or 5 years down the line, we'll see many more gatekeepers and many more countries on that list. I take this opportunity to thank you, and really, on behalf of everybody, appreciate the depth and the weight of knowledge that you have. And I request everybody to give a round of applause for this.